Hello, so we'd like to look at a few questions from Algebra 2. Alright, let's get started here. To do that, we'll take out the graphing calculator on the side. So in the triangle PQR, length of the side P is 212 and then Q is 287. The measure of the angle R is 124. So why don't we assume that the triangle will be something like this. A bit longer. This would be 212. This is 287. And that means this is Q, which makes this one to be Q. When this one is P, then opposite side will be, or opposite angle will be angle P, and then this is R. And measure of the angle is 124 degrees. To find the area of the triangle, we will be using 1/2 AB, which is 2 sides, and sine of the angle in between, sine of C. Then here what we end up getting is 1/2 212 times 287 times sine of the angle between them, which is 124 degrees. Now, let's put that into a calculator. 0.5 in place of 1/2 212 times 287 times sine of 124. Now I just want to check the mode. It's in degrees. That's great. So once we calculate that, it becomes this value. So put it to the nearest tenth. So we're going to have 2522. Put it to the nearest tenth. That means it becomes 8 has to go up, so which makes 1, 0. That becomes our answer. Alright, let us move on to the next question. Find the exact value of the area of the isosceles triangle whose, if the measure of the leg is 12, the measure of the vertex angle is 45. So that means here we have, once again, area is 1/2 times 2 sides, which is equal to 12 times 12, times sine of the angle between them, which is, here vertex angle is 45 degrees. And what is this in fact equal to? So here we have 1/2 times 12 times 12 becomes 72. Sine of 45 becomes radical 2 over 2. So we end up getting 36 radical 2 becomes our exact answer. Now, following question here, we have a pair of the angle, and then the side. Angle, and then the missing side. That means we have to use the law of sine. So law of sine says A over sine of A, which is equal to B over sine of B. Now we can write it in this way, or sometimes sine values are in the numerator, and then the length of the side tends to be in the denominator. Either way is perfectly fine. Here we have 24 over sine of angle A, which is pi over 6, has to be equal to B, which what we're looking for, times sine of pi over 2. Then here we have 24 sine of pi over 6, which is sine of 30, which ends up being 1/2. That's equal to B over pi over 2 is 90. In other words, this becomes simply sine of 90, which is equal to 1. That means 24 is equal to 1/2 B. If you have to multiply by 2 on each side, B would be equal to 48. And that becomes our answer. Now, we have 2 sides and the angle, 2 sine ratios, and then length of one side is given. Then here we have p over sine of p, which would be equal to 40 over 3 over 4 must be equal to value of r, which we do not know, over sine of r, which is 2/5. Once again, once you cross multiply, we'll end up getting 40 times 2 over 5. And then 3r over 4. Now here becomes 8. 8 times 2 becomes 16. So we have 16 is equal to 3r over 4. Once again, cross multiplication one more time, then we end up getting 64, which is equal to 3r. Therefore, r is equal to 64 over 3. That becomes our final answer. Number 12. We have two angles, and same thing, but in this case we might have to use the calculator. So here we have 25.8. That is the length of side A. Therefore, I'm going to match that with sine of 102 degrees. Has to be equal to C, which we do not know. But we need to find the sine of C. How do you find the sine of the C when angle A and B are given? That's right. C, measure of angle C, must be 180, which is equal to, from entire triangle, subtracting the other two angles here, 102 and then minus 34. Then here we have 78. 78 minus 34 becomes 44. So we end up getting sine of 44 degrees. And let us cross multiply them. We end up getting 25 times if I have to put this one over onto the other side, 25.8 times sine of 44. So one side comes out to be this way, which will be equal to 17.9221 or 222, and C times sine of 102. To find the value of C, we have to divide by sine of 102. So from here, we're going to divide that by sine of 102. Then our answer for C, therefore, is equal to 18.32. So therefore, 3 becomes our answer. Number 16. The base of an isosceles triangle measures 14.5 centimeters, and vertex angle measures 110 degrees. So if I were to draw a picture So if you're to assume that this is the picture that we have, base of an isosceles triangle measures 14.5, so this becomes 14.5, and then vertex angle measures 110 degrees, so that's one pair that we know. Find the measure of one of the congruent sides of the to the nearest hundredth. Since these two angles are congruent, you get to realize that this must be 35 degrees each. To find A, why don't I call this side as A? Then we get to realize A over sine of 35 must be equal to 14.5 over sine of 110. Then let us try to look into this one. In order for us to find A by itself, we can multiply by sine of 35. So 14.5 times sine of 35 divided by sine of 110. Then that's what we end up getting. (14.5) times sine of 35 divided by sine of 110. So the length of one side becomes 8.9. Same for the other side. Find the perimeter of the triangle to the nearest tenth. That means since it's an isosceles triangle, we end up getting 8.9 plus 8.9 plus 14.5. So if you combine them together, therefore our final answer seems to be, for the perimeter, is 32.3. Alright, let's look into the next question here. Determine the number of possible triangles for each. So in this case, there are a few ways for us to approach this one. But let us try to use the law of sines here. Then what do we end up getting? Pair of these two, which is 8 over sine of angle A, has to be equal to, in this case it will be 20 degrees tan over sine of angle B. I have no idea what that is. So when we cross multiply, then what we end up getting is this. 8 sine of B must be equal to 10 times sine of 20. When you divide by 8, we get to see something. Let's put that into the calculator. Ten times sine of 20 degrees divided by 8. So sine of B would have been this one. Therefore, in order for you to find the measure of the angle B, what we need to do is this. We need to put the second sine that we are looking at, and then the answer. So the measure of the angle seems to be 25 degrees. But sine can be positive in two locations. One location being in the first quadrant. Another thing would have been on the second quadrant. Using this one as a reference angle, we get to realize that the another measure of the angle could have been 180 minus 25, which would be equal to 155. Now let's see if both of them are possibility. First case was this, 25 degrees, given that the angle is 20 plus 25, which is 45. We have room for the third angle. How about here? Well, 155 plus 20 becomes 175, and then it is possible for the third angle to be 5 degrees. So in this case, we have both answers would have worked. How about number 6? So here we have 6 over sine of 45, which is equal to 10 over sine of C. Here we end up having 6 sine of C must be equal to, let's look into this one, 10 times sine of 45. Let's turn everything into the calculator. Ten times sine of 45. And that's the value which we would have gotten. And then divide by 6 would have given us 1.17. Now, if you think about it, can sine value ever be equal to 1.17? It's not a possibility. So therefore, there will be no triangles. formed with given condition. Alright, so let us move on to the next question. Oh, that's it. I'll see you later. Bye-bye.